Here we have a special case integration by parts example problem that you might not run into very often, but when you do, it's important to know. So here we have the integral of e theta cosine of theta d theta. And the first step we want to take in using integration by parts to solve this is we want to determine our u, du, v, and dv terms. These are the terms that we'll use in our integration by parts formula. So we can go ahead and select our u to be cosine of theta. Our dv will be e theta d theta. The du term we can find by taking the derivative of u to get negative cosine theta d theta. And our v will be the integral of e raised to the theta d theta, which is just e raised to the theta. So the next step is we want to plug in these four terms into our integration by parts formula, which is just uv minus v du. So here we have it, the integral of e raised to theta cosine of theta d theta. This is what we were given earlier as our example problem is going to be equal to uv cosine of theta e theta minus v du, or e raised to the theta multiplied by negative sine theta. So we can go ahead and simplify this to get e theta cosine theta plus e theta, the integral of e theta sine theta. And when we look at this term, we notice that we'll have to do an integration by parts again. So we'll do the exact same process for selecting our u and dv terms, and we'll take the derivatives and integrals as such. So here we have it, u and du for our terms, and dv and v for our terms here. And so we can go ahead and use our integration by parts formula, uv minus v du. And when we simplify this, we'll see that we have in our integral e theta cosine theta. So this is the exact same integral that we started out with. And so you might be wondering at this point, we're going in a loop, right? What am I supposed to do? And so here is the trick. We can go ahead, because this is a minus sign, we can go ahead and add it to the original starting point. So here we'll have the integral of e theta cosine theta d theta, which is going to be equal to our terms that we determined before. And so here's the trick. We can go ahead and divide this to the other side. And so now we'll get our expression, our example problem, our original example problem. The integral of e raised to theta cosine theta d theta is going to be equal to 1/2 e cosine theta plus e raised to the theta sine theta plus c. So this is our solution for this example problem. It's a little bit tricky, and here is the main thing you have to watch out for.